This is my session, just a quick overview, introduction to FireMonkey for iOS and Android. And I've got the ID here. What I'm running on, I've got my MacBook Pro notebook. I'm running, let's see if we can see it here. No, this one's probably the right way. I'm running Parallels Desktop 9, and I've got my iPhone 4S connected over here. So let's go over to the Macintosh side. And I've got the PA server for XE5 loaded here. I put a alias on my desktop so it's easy for me to double click. And the PA server is used on Macintosh so that the Windows ID can send applications to Mac OS X. I'm running Mountain Lion. Mavericks is not out yet. It should be out any day unless I missed something in preparation for CodeRage.
Yeah, I saw that the Gold Master is available to developers, but yeah, it should be out any moment now for everybody else.
For users, yeah. And then I also have, there's a built-in PA server on Windows so that I can go from my Windows IDE. Oh, let's see. What is this doing?
Now, we still get the question that if you need to have a Mac for iOS development, and the answer is yes, but there's an alternative using Mac and Cloud, and that's you need a trial with that built into XE5s.
JT had a few slides that were similar, so I'll skip past those very quickly. This is me. Those are all the ways to follow me, link me, connect me, send emails to me. JT showed this. Those are the 4 different platforms, Windows, Mac, iOS, and Android that we currently support for Delphi and XE5. And again, winter time is when C++ version for mobile for iOS and Android is planned to be released. JT showed this one that FireMonkey and the RTL combination with your code allows you to connect to Windows, build apps for Windows, for iOS, for Android, and for OS X. For iOS and OS X, we create app bundles, and you take the app bundle and give it to somebody on a Macintosh, and they can just run it, and everything's good. Install it. For iOS, we also have the option in Target Platform to generate either an ad hoc target, so you can ad hoc deploy it if you've got an enterprise license and so on. And then we can also create a store application so that it's ready for you to go through the steps if you have an iOS developer account with Apple to submit your apps to the App Store. And we have lots of different iOS-based Delphi apps that are in the App Store now. On Android, we generate a .so and then package that up in an APK. We have a little Java loader that loads up the code that's in the shared object that's buried inside the APK, and that's your Android application coming up. So I don't know what this new software available from Galaxy S4 is going to do over there, but I hope it doesn't do anything bad. I guess I can cancel it for now. That's a good thing. All right. FireMonkey's been out, or now we call it the FM application platform, because people were wondering why it's called FireMonkey, and there's no really good answer. It's just a name. So now we refer to it as the FM application platform. It allows you to build 2D and 3D based applications. It runs on Windows, OS X, iOS, and Android. It's native code using all the different compilers that we have for Delphi and C++ for desktops and for the ARM processors. Lots of user interface components and non-visual components that are part of building the complete application. Full support for laying out your applications with layouts. We have flow layout and grid layout and just a general layout. You can do anchoring to anchor buttons and user interface controls. You'll see some of that in the examples. You can align components center them, left align, right align. There's full gesture support because these devices, iOS, Android, and some of our touch notebooks, even the Macintosh, you can use the trackpad with 2 fingers to do gestures. So gestures have been added to, especially for these touch-based machines, which are all these devices, tablets and phones and so on. FireMonkey itself then integrates with the graphics systems, whether it's Core Graphics or OpenGL or whatever, or DirectX on the different platforms. All of that is done under the covers. And again, you can always get to the operating system. You can always get to the hardware through the interfaces and the APIs of each of the operating systems. If you want to do image processing and animations with images, then FireMonkey from the beginning has had support for image processing using Pixel Shader and the GPU, Pixel Shader 2.0 and greater, and lots of animations to do transitions between an image and another image. So all of that is supported. And again, we use the GPU on desktop and mobile devices to do a lot of the work to offload the CPU. And that's talked about in the documentation and is done under the covers again for you based on components that you use. All right. We also have support for some of the native controls on iOS and Android to text editing, for example, with T-Edit and T-Memo, so you can have the built-in support for cut, copy, paste, zooming, and so on, select and select all. The phone dialer, the date picker, custom picker, notifications and alerts, and support for the virtual keyboards, both on iOS and Android, based on setting the keyboard type. As I mentioned, anchors and alignment. There's a form family property for forms so that you can specify different forms for different devices and orientations. And you can use a form family. Form family is just a text name for each of your forms. So if you have the same name and the startup code sees that you're on a tablet versus a phone, then it will load the right form for you. Otherwise, you can always write code to load different forms by querying what device that you're on. Again, I mentioned the gestures. We have the standard gestures, and we also have the interactive gestures of tap, tap and hold, double tap, or tap and hold, sometimes called the long tap, pinch and zoom. Those interactive gestures are available across all the platforms that we have gesture support, which is Windows, Mac, iOS, and Android. We don't have customized gestures. We only have those on Windows right now. But, stay tuned for other things that will happen in the future. But with, 32 standard gestures and the interactive gestures, you can basically do just about everything you would need from a user interface standpoint, especially doing swipes between different tab sets and so on. For mobile components, there's been mobile-specific additions, things like camera support, magnifier, the web browser. We have a list box, which is good for short lists, with very complex entries where you can composite up lots of things into a list box item. Of course, you can put text in list box item as well. If you have longer lists, for example, maybe 1,000 customers, we have the T-list view component, and there are lots of different sessions in CodeRage. So I won't go through all of these because there's specific breakout sessions on when to use list view versus list box, when to use how to do database access, how to use different parts of the user interface elements that are there. Serena has a session on how to improve the user experience or design for the user experience as it relates to using FireMonkey and all the components. And that's coming up in a couple sessions today. So I'll leave it to Serena to talk more about ListBox, ListView. And there's a separate session specifically about optimizing and choosing between the two. Obviously, the on-off switch, which is like a checkbox and has a is checked property. With T-switch, you have an on-switch event handler. Then the default event handler is on-switch. Progress bar is there. That's fine and used for lots of different options. And a speed button. The nice thing is with the styles on iOS, you can change the style of what the speed buttons look like, maybe with icons and text. The wizard is the best place to start with the new mobile application. We give you project templates for the common types of mobile applications, both on iOS and Android. All starts with File, New, FireMonkey, mobile application versus desktop. Okay, let's switch over to the IDE, which we should see. There it is. Okay. So File New is a good way to start. We have two different options, FireMonkey desktop application, FireMonkey mobile application. There's some extra startup code for a mobile application having to do with settings as it relates to deployment across the different devices. So if I go in here, for example, and say File, New, View Source, you'll notice that on a mobile application, there's a system.startup copy is the first unit that is inside of your main program. Everything else after that is the, of course, FireMonkey form unit, and then any units that have forms that need to be created. It all starts with, in the body of the main program, application.initialize, application create form. That, again, is over here if you haven't done this in a long time. Under forms, you can have auto-create forms. Whenever you put a new form and make it an auto-create form, then in the main program, it'll have that create form. You can also have available forms, which means they're forms that you want to create and show in your code at some point in time. so they won't necessarily have to be auto-created. But if it's in auto-create, then this line of code gets added, create form, and then the fantastic application.run call. This is the distinction and main difference between building a desktop application, a FireMonkey app. The startup copy will take things that are in project deployment, so different parts that have to get moved depending on the target platform into different subdirectories inside of your sandbox on the different platforms. Here in XE5, the default target platform is Android, and so I have my Android device connected. That's here. It's a Samsung Galaxy S4. We also pre-build a link to the Android emulator. Android emulator is what's the right term for it, Jim? I don't want to say it's slow.
So the difference between the Android emulator and the simulator on iOS is the emulator actually emulates the ARM processor. So because of the fact it's emulating all of this, it actually is slower. Now, the interesting thing about that is that on iOS, when you run on the simulator, you're actually going to be faster than your actual hardware. And so it gives a false perception of your application being more performant. You deploy it to hardware, and it's like, whoa, it's all of a sudden slower. On the emulator, the reverse is what happens. So if you test on the emulator, you're going to see it slower than the actual performance will be. Most Android developers I've talked to on any tool they're using, they use actual hardware for most of their day-to-day testing, and then use the emulator if they need to test different UI configurations. So definitely pick up couple pieces of Android hardware for your testing purposes.
If you're doing iOS or Macintosh development, we do need to know where the Macintosh is or Mac and Cloud is, so that we can find where some of the libraries and debug symbols in the libraries. We don't have a redistributable SDK from Apple. Those things are just included in a Macintosh and Xcode, including command line tools. We need the command line tools for doing things like code signing an application. And that's just a license requirement from Apple. They don't allow us to redistribute any code, whether it's binary code, source code, and so on. That's Apple. Versus in Windows, we get the Windows SDK. We have a license for it. We have the debug version and the release version of the SDKs. And so we can package all of that up in the install. Android is open and available, and so we install the Android SDK as well as the native NDK for you. This one, and then I can just make sure. One of the other things that I use occasionally Xcode for is looking at the device log. So yes, other apps, Words with Friends crash, BBC News crash, you can use to get some information about crash that might happen. It also lets you know that you're connected, that you have your provisioning profile set, your developer key, and so on. And so it's useful for a couple things that way. But the ID just needs Xcode installed, and the PA server knows where the different bits are. And that's all I need. Otherwise, I'm not using the Xcode ID for anything. I think Danny and Daniel did a session in CodeRage Mobile where they used Xcode has these things called instruments that could do things like memory profiling and execution profiling. And that works fine with Delphi iOS apps as well. So you can take a look at their session replay from CodeRage Mobile last June. And that's the case where you might want to explore using Xcode for additional part of a tool set for using some of the instruments for memory utilization, for example.
And then I have a session beyond the app that I believe is later today, and I'll talk about how to do debug logging, and then you use Xcode's console view to view that from your mobile device.
Let me make sure I can connect to my Macintosh side. So we'll just... the
DNS on Mac versus Windows is actually a different creature. Okay. So I find the IP address always...
Yeah, so there's the IP address. So I connected there. And the same thing over on Android. When it's enabled, it's there, and we can go and look at the target information. We set up the SDK. There's the SDK manager for Android and the SDK. So when I set up an SDK for iOS, here's the location of all the libs over on my iOS side, and this was all connected because of the ID connected to the PA server, and we can always click update local file cache, which just updates where all these files are as part of the linking and deployment on iOS. On Android, we have the SDK path, and we have the signer. Here's the code signing path. We've got the native SDK or NDK API location, so you can set these yourself if you've installed the Android SDK NDK somewhere else. If it's part of our install, we create one for you. But if you've got it somewhere else, you can go in and add another SDK target. SDK NDK target for iOS and or Android, and give it a name, and then use it in your build system. Up here in the designer, we've added in XE5 the ability to choose different form factors, and this is for your design experience, so you know where to put your layouts and your components and so on. You can also go up and through Tools Options, you can create your own, choose a custom one, for example. It could be a custom device where you give it a name and a bitmap boundary for, whether it's an LG phone or an HTC. Well, I guess, let's see, do we have HTC or an HTC or whatever it might be? You can put a bitmap in there and give it the client area coordinates so that, you have an affinity for what it is that you're looking at. So I've got an iPhone 4 here. Let's just hit F6, and we'll put a button down. That's Code Insight. And now we have a button. Let's go and put the button down here. This is the simplest. Let's put a label down, and we'll put the label here, and we'll put an edit box up at the top. And then let's put that edit box up here. All right, and then the label underneath it, maybe a little bigger, so it's the same size as that. Change the caption. This is all standard design time and using the object inspector. So click me, and notice now I've got the iOS 7 installed, and this is an iOS 7 device, even though over here it says iPhone OS 6.1. That was the name that I had before because I updated from 6.1 to 7.0.2 now. So I need to just change the name of that at some point in time. But it gives me that look based on what phone I have connected and what it's running. And again, this case is iOS 7. If we go and because of the iOS 7 update that we did right after we shipped, just before iOS 7 was released, now when I choose iPhone, I have iOS 6 and iOS 7 look. So there, notice at design time, I can see the new look of iOS 7. Whether you like it or not is a different story. That's for everybody to decide. And then for my Galaxy S4, again, here's a button, and here's the edit box, and here's that label. Let's go to the iOS device, and let's change this look here. And we know that's going to run. Here comes that Project 1 icons appearing. There's the FireMonkey flash screen, and here's the application. So I can just go in and say hello, right, and say done, and click me. And you know what I forgot to do? That was so funny. I'm such a bad programmer. Well, it's live, so I never put the event handler. Text is going to get edit1.text. Okay, and hit run again, and then we'll go back. So now it's coming up again, and here we have the label. So here I didn't put anything in, so hello. So that's just, simple first FireMonkey app and orienting yourself. Here's a location example. Location uses location sensor. I have a talk later today about using sensors and devices. So we have a location sensor component. Is one of the 3 sensor components that are available. And then there's, of course, lower level sensor APIs as well. So all the sensors are listed down here. Is location sensor, motion sensor, and orientation sensor. Here's a switch component and a number box. And down inside of each of these user interface components, there's a keyboard type, and this is using the default keyboard, but let's instead make it a number pad. And the same thing for accuracy, make a number pad. So when I click on those on the device, it will come out as the right type. Okay, and now we'll just run location on the device. So location, what it's going to do is the code is going to take the latitude and longitude from the location GPS device that's in my mobile phone, and it's then going to call to Google Maps, passing the latitude and longitude and getting the results back and displaying it in an area on the form where I've got the T web browser component put down. And here it comes. And so location is there, and it should start up. Here it comes. So we'll use the switch component and turn on the sensors by sliding it to the right. And now it gets the latitude and longitude. And down below in the lower area, it says that we're at 5619 Scotts Valley Drive. And that's where we are. I can change the trigger distance, something so that it doesn't trigger a change, at every time the location changes. again, it looks, we're getting small micro changes, and we can set the accuracy as well. And then and see that updating as we're getting new data updates from the GPS device. We're also here inside of a building, and so it's working sometimes, and sometimes it's a little sporadic. Then we can turn the location sensor off, and then it'll have the last choice that's there again with the latitude and longitude with Google Maps. If we go back and look at the code behind, again, it's pretty straightforward. We have a string here, which is the Google Maps with %S and %S, and then we'll use the location that we get on location change. So when a location change event fires, we get the old location and the new location as the coordinates 2D. We'll put into the edit boxes the new locations, latitude and longitude. We'll use the format method to put the latitude and longitude using these helper functions to string, which will convert the latitude and longitude into strings, and use the format to embed those in replacement for the %S, and then use the web browser component and navigate to that result. And the web browser component is just down here in our user interface, T-Web Browser. T-Web Browser works on iOS and Android. We don't have a T-Web Browser component yet for Windows and Mac, but we're looking at that. What you could do is if-def your code, and you could use a shell exec on Windows to launch a separate window and have Google Maps show up in that. And you could use the system call on Mac OS X to pass a URL and have it launch whatever the default URL browser, if it's Safari or Chrome, whatever you've set it to. I think Safari on OS X is the default one. So we could always do that kind of user interface for desktop where you have more space to put a separate window from your location. And we have lots of different examples for all of those as well. Let's do the share sheet example. What share sheet uses, it's got an image component, and it's got actions, an action list. The action list, there's two actions that are hooked. Show share sheet action and take photo from camera action. There are some standard actions that have been added in XE5. 3 in particular for the media library. Take photo from library, that's your camera roll, or take photo from camera, and then call the share sheet API for iOS or for Android. So you can take a picture and show it, and then use share sheet to send it to Facebook or Twitter or whatever the shared applications that know how to deal with images. The code behind this is 2 lines of code. One is before the share sheet action executes, we want to take the image that is on the desktop of the device, take its bitmap and assign that to the bitmap of the share sheet action so it can be shared. And the take photo from camera action, if you said you took a picture and said use that picture versus cancel, don't use it, then before it finishes taking the picture, we're going to get the image, which is a parameter, and we're going to assign it to the desktop image, which is called image camera picture, which is this one right here. So let's run this on iOS, and we're still connected. So let's run this one, and we'll use Jim as the subject matter here, or as the model. And so now again, it's compiling this application. He'll give that nice Jim McKeith pose. And again, these actions, the gestures, you'll see more of this today in Serena and the other talks as well, is all just part of building a FireMonkey application. In the case of ShareSheet, that works on iOS and Android. There's no specific sharing mechanism on Windows and OS X, but there are APIs that you can use. But on the mobile devices, it's 2 lines of code and 2 standard actions that you hook. So here comes the splash screen. And again, now I've got a couple buttons here. So let's click the take photo button. And now you'll see Jim there working here at CodeRage. So we'll hit the button. We've taken the picture. And now we'll click the use. That's an okay one. We'll say use photo. And now hit the share button. If I hit that right, there we go. So on my iOS phone, I've said these 4 applications at the top can know something about sharing bitmaps. And then we've got some other things at the bottom, like save the image, print it to a wireless printer, for example, which I have at home. So let's choose Twitter, and then I can say Jim in the studio for CodeRage. And I should put the hashtag on there. Oh, it was there. Okay. Right. And then post that. Let's go to Facebook and let's go and post this. So Jim Studio, same problem at CodeRage. And let's post that to Facebook. And so now if you go on Facebook, the David I account, I'm David I think I'm just David I. It might be David I99 on Facebook. That picture will be there, and I'll get this logged in. Let me just bring up a couple examples that I've built. Here's a gyroscope, so that uses the orientation sensor. And so we can, move this 3D cube around. And what you can't see is me moving the phone around in three-dimensional tilt and so on. So there's...
Imagine that cube is the phone, and you'll know what it looks like.
Yeah. So we have access to sensors, browsers. This is FirePhoto. This app is actually in the App Store. You can search for it, FirePhoto, and download it. So it allows you to, again, take pictures. So here's Jim again. You're going to get it all the time.
And Alf reports that your picture you posted just showed up on Facebook.
Excellent. So here we've got a 2D form, and we have a 3D viewport. And in the 3D viewport, we've got two spheres. So here's 3D viewport to show that we can put 3D into a 2D app. We could also put 2D components using a layer in a 3D app. And then we've got a sphere for Earth and a sphere for Mars, and we've got a float animation to get the Earth to move around. And then we just load up these textures for the Earth and Mars. Those are loaded up at design time, and then as we do the form create, we just start up two float animations, which will do the rotation, animating the Z-axis to rotate them around. Okay, so there's my Android desktop. So now we get latitude and longitude, and we'll get the Google Map. So this is that same location app, same source code, running on built for Android. So it's got the location sensor and then the T-Web browser running over there. Let's go back and do. So here's the date picker. So here's the Android version of the date picker. We can roll around and then set the date, and then it puts that into the label at the bottom.
And that's the native date picker. So if you're running a different version of Android, it will look different.
It will look different. Same on iOS. You'll get the animated date picker, and here it comes. So here's the planets. Let's turn it over here. So we use the switch and turn on rotation, and it's going to look jerky because Jim's version is just grabbing about a frame a second, something like that.
Screenshots.
For screenshots through the debug interface. If we had the VNC, you'd see these nice rotating Earth. And again, we're just using an animation to animate the floating point property of the position Z, of the Z-axis position, to rotate the planets around. Now, somebody wanted debugging, so let's use a different example than this 3D one, just for fun. Okay, and let's go back to that share sheet example. Okay, so before this finished taking, let's hit put a breakpoint. Debugging is the same. You set a breakpoint somewhere in your code, and then you have full access to the CPU viewer and to complex breakpoints, and you can use the debug windows to step through memory and look at instructions and evaluate variables, all the things, set conditional breakpoints, how many times through a breakpoint, hit it on every 50th call, something like that. So now it's coming up, it's there, and down here is the... Okay, so there's my take a photo. So if I click take a photo, and then when I did finish taking the photo, there's Jim again. Now you see share sheet going, and let's save that picture. And now I've hit the breakpoint. So we can go up here and say view CPU viewer, and it's time for me to finish. But here, these are ARM registers. These are ARM instructions. Here's our source code. Down here, we've got any variables. We can add variables to the watch window and so on. So everything that's in the debugging experience, and then we can just continue running to here and say share. And then here's the different applications that I have for sharing. So there's Twitter, and now again I'll have that picture with Jim. There's the picture of Jim. It's coming up, and I'll say, you know, sharp CodeRage and right, and then say OK, and then we'll tweet that and sending the tweet. And now Jim, and that one I was logged in on this device. So somebody on Twitter, I'll probably see a picture of Jim here in the studio. So again, there's lots of sessions happening here at CodeRage. There's lots of documentation for building mobile applications. There's at the highest level in DocWiki, there's all the information you need on the application platform. For tutorials, there's 14 tutorials on building mobile applications, and all of that has been put into an ebook as well. So you can just use this. I know these URLs are very long, but you can just search for mobile application tutorials, Android, DocWiki, Embarcadero, and you'll get there, and we'll make all these links available. Can you guys include a gaming demo for FireMonkey? Well, we're not doing games. Some other people are doing some games. There's a trivia contest app that's in the iOS App Store for answering questions about the states, the capitals of the U.S. Is it possible to create widgets for Android and XE5? Not currently. Jim is looking at what we might be able to do, and as far as widgets are concerned. So stay tuned for that. And then some project template work probably that R&D is going to ultimately have to do. No T web browser for FireMonkey desktop. Yes, there isn't anyone currently. R&D is looking T web browser. Oh, Paul said, forget that. In location example, there was a bug. Let's see, where did it go? If the decimal separator is a comma, the application can't work. Yep. So what we'd have to do is write some special code that would scan across the string and looking for a comma and putting a decimal point. Or you could set the format specifier to have decimal points for latitude and longitude. Sandra was having issues in playing video files. I did a blog listing all the different video file formats that are in FireMonkey. In the case of iOS, it'll play video in a window or on full screen. In Android right now, T-Media Player plays full screen only, and that's written up, and there's an example in the DocWiki. So look for T-Media Player Android video. Right now it's full screen. The T-Media Player control is the place on iOS that you can play video in a window, as well as on Windows and OS X. The T-Media Player connects to the file that the video is coming from. The T-Media Player control is the visual area on Windows, iOS, and OS X where the video will play. And for now, we give you the code for playing video in full screen on Android, and they're taking a look at what to do to be able to play video in part of your application for Android in an update. iOS supports new multitasking APIs. Is that in XE5? I'm not sure we wrapped that API yet, but stay tuned for Delphi unit updates. Of course, you can always connect from Delphi, and we have lots of examples. Look at sensor info. Sorry, look at the device info mobile code snippet. So device info, and that shows you how to use the Objective-C class bridge and also the Java class bridge technology to get to any APIs that use iOS types and Java types on Android. ByteEye support, yeah, R&D's looking at ByteEye support. Somebody's asking when is there going to be an update. R&D's working on an update with some bug fixes, and it'll be ready when it's ready.